so on the last video we talked about dihybrid crosses when we had purebred parents. So our parents, remember, were capital R, capital G, that was one parent. The other parent was lowercase r, lowercase g. So this parent was homozygous for both traits, because remember, R is the trait for the shape, G is the trait for the color. So this parent is dominant, so it was round and green. This parent is recessive, it is wrinkled and yellow. Okay, so these were our parents. We crossed them in a dihybrid cross Punnett. We got 16 offspring out of that, and we found that every single offspring was exactly the same. Each one was heterozygous for each trait. So we had 16 babies that were going to be capital R, little r for a genotype, which means their phenotype would be round. Okay, all the babies would be round. And then in this one, all of the P's were capital G, lowercase g. They're heterozygous again for this trait, so they all come out green. So all of our F1 generation is round and green. So now what we're going to do is we're going to cross our F1 generations and see what we get in an F2 generation. Remember, all of the F1 generations were exactly the same. They all had this genotype, capital R, lowercase r, capital G, lowercase g. So now let's go through and make another dihybrid cross. Down a little bit. And remember, when you make a dihybrid cross, you have to have 16 squares, not 4. So that makes it 4 times the fun, right? Okay. Remember, just like when we were doing our old Punnett squares, only one allele for each trait can go up top. Okay? Remember how when we had one parent was big B, and one parent was little b, right? One here, one here. One here, one here. Same thing, okay? Only one allele for each trait can go above each square. So, for the first parent, they're both the same, so we know we're going to get the same thing. So, for the first parent, okay, we can use this capital R. Capital R maybe with a capital G. Okay? Second one, this capital R could then also go with a lowercase g. Okay, now we're done with our capital R's. Now let's look at our lowercase r. Lowercase r could go with a capital G. Lowercase r could also go with a lowercase g. And boom, there we have it for one parent. Okay, we have all of the allele combinations for one parent. Well, we know that both our parents had the same exact genotype, so we can just fill out this same thing right down here. So capital R, capital G, capital R, little g, little r, capital G, little r, little g. Now we have to draw a Punnett square. A little more complicated than the last one because obviously they're not all going to end up the same. Okay, so we have to pay close attention. So this square, just don't get terribly confused. Don't think of it as RG. Just look at the R's. Just start there first. Okay, this one has capital R, okay, and it has capital G, Easy, right? Okay, this one has capital R, capital G, lowercase g. This one has capital R, lowercase r, capital G. This one has capital R, lowercase r, capital G, lowercase g. Okay, so now we just go through and we fill that out for all of them. This one, capital R, whoops, capital R, capital G, lowercase g, capital R, lowercase g, capital R, lowercase r, capital G, lowercase g, capital R, lowercase g. Okay, next line. It takes a while. We'll get there. Okay, capital R, lowercase r, capital G. Okay, capital R, lowercase r, capital G, lowercase g. Lowercase r, capital G. lowercase r, capital G, lowercase g. Last one. All right. Capital R, lowercase r, capital G, lowercase g. Capital R, lowercase g, lowercase g. Lowercase r, capital G, lowercase g. Lowercase r, lowercase g, lowercase g. This is our F2 generation. So these are all of the 16 combinations of these parents that they could make with these two traits. Now we know the genotypes. Let's go back and look and see what the phenotypes are going to be and write down the phenotype ratios and the genotypes. All right. So remember, round is dominant for shape and green is dominant for color. So let's look at this. Here's our first phenotype. So we have capital R, capital G, lowercase g. Okay, we have one of those so far. Next up is capital R, capital G, lowercase g. We have one of these so far. Capital R, lowercase r, capital G, we have one of these so far. Capital R, lowercase r, capital G, lowercase g. We have one of these so far. Capital R, capital G, lowercase g. Look, here's this one again. So we have another one of these. Okay, so we'll mark it. Capital R, lowercase g, g. We don't have that on here, so we need to write it over here. So capital R, lowercase g. We have one of those genotypes. Next up, capital R, capital G, lowercase g. Here's another one of these. Capital R, lowercase g. We don't have one of those, so let's put that up here. Capital R, lowercase g, g. We have one of those. Capital R, capital G, g. Here's another one of these. Capital R, capital G, g. Here's another one of those. Lowercase r, capital G. That's a new one. One of those. Lowercase r, capital G, lowercase g. One of those. Capital R, capital G, lowercase g. There's another one of those. That seems to be a pretty popular one. Capital R, lowercase g. Here's this one. Lowercase r, capital G, lowercase g. That's that one. And last but not least is lowercase r, lowercase g. We have one of those. These are all of our genotypes. Okay, so these are all of the allele combinations that we got out of this. And as we can see, we have a lot of variation, don't we? I mean, before, the most we would really have is like, what, 4, okay? Look at all of this variation that we have. But what are the phenotypes? Okay, let's look and see. I'm going to use a different colored marker for the phenotypes. I'm going to use red. All right, I think red's good. Yeah. All right, so this one is capital R, capital G, g. All right, so we're done with this. I'm going to erase this. All right, so this one is round and green. Okay, we have one round and green. This one is round, okay, and green. It's heterozygous, but it's still green. This one is round and green. Remember, as long as there's a capital letter for that trait, it's dominant. So this one's round and green also. Look at this one, round and green. Look at this one though. This one is round and yellow. So that's a new phenotype, round and yellow. One of those. This one is also round and yellow. This one is yellow, this one is wrinkled, okay, and green. So this is a new phenotype, wrinkled and green. So there's a phenotype for that one. All right, then we have wrinkled and green again, here. And then we have wrinkled, and yellow. Now, one thing I kind of messed up on, and I'm not going to start this video over. I should have actually put how many there were of each one. So when we go back and we look at the round and the greens, we have 4 different ones that are round and green, all of these, and it's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 9 of them are round and green. Round and yellow. Round and yellow. Round and yellow. Look here, there's a total of 3 that are round and yellow. Wrinkled and green. Wrinkled and green. Wrinkled and green. There's a total of 3 that are wrinkled and green. Wrinkled and yellow, only 1. Right? So this is how we do our dihybrid cross, and this is all of our F2 generation. Now, obviously we could do more and more and more crosses and figure out how to get different traits that we wanted to get out of them by crossing all of these different alleles, right? So remember, F1 generation, we crossed purebred dominant, homozygous dominant for both traits, with homozygous recessive for both traits. Out of that cross from the original parents, we got an F1 generation of 16, and all of those were heterozygous for each trait. So all of those were capital R, capital G, little g. We took 2 of those F1 generations, we bred them together, and this is all our F2 generation, okay? These are the genotypes that we got out of it. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 different genotypes from that combination. And then we see that we got 9 offspring phenotypes that were round and green, 3 that were round and yellow, 3 that were wrinkled and green, and 1 that was wrinkled and yellow. All right? So that is how you do the dihybrid crosses. If you have any questions about it, we're going to keep going through the lesson plan. We're going to do a couple more examples, but you really need to understand how to do this properly. If you have any questions, please email me.